Hi everybody, welcome to the second Project Lead the Way Algebra review video for Principles of Engineering. In the first video we went through 4 different processes using some general equations, but this time I'm going to be using the same processes as we did in the first one, but this one applying them to problems specifically found in POE. Now if you remember the first example, all we really did was simply rearrange equations to solve for the unknown value. The formula we're going to be working with in this case has to do with work. Now the equation for work is pretty straightforward. It's work is equal to force times distance. Now you may have learned it as force times displacement. I'm just going to use force times distance to be consistent with the Project Lead the Way program. Now the problem we're going to be dealing with in this situation has 2 of the 3 values being given to you and having to solve for the third one. So we're going to say in this case that the work in this problem is 150 joules. Now this is a situation where you would be given some information, you would have to pull it out of the description of the problem and use it in the equation, but we're going to focus just on the math aspect of it. So the work is going to be 150 joules, and the distance traveled is going to be 20 meters. So distance is going to be 20 meters. And I have a habit of writing down the known information just so I have it all easily found in case there gets to be more information or if there are more calculations we have to do. So all we have to do in this case is just solve for the force. So work is equal to force times distance. The work in this case is 150. I'm going to leave the units out of the equation for right now because that can get confusing sometimes. So work is 150 joules is equal to force, which is the unknown value, so I'm going to use it, leave it as the variable f. Now if you feel more comfortable using x as your variable for these kind of calculations, that's fine. But at some point you should progress to the point where you are using other values, other variables, or other letters for your unknown values, because it gets kind of confusing if you're doing 17 different calculations and each one of them has an unknown variable of x. So 150 is equal to force times, and again the distance is going to be 20 meters. And the way you solve this is pretty straightforward. You divide both sides by 20 because you want to get the unknown variable by itself. Plug all that in, and 150 divided by 20 is going to be 7.5. So the force is going to be 7.5. And since we are dealing with actual calculations, we need to include units. Now in this situation, work being in joules, distance being in meters, force is going to be measured in newtons. Okay, and I'm also going to put a box around the final answer so it is easier to find later. All right. So again, this equation was basically just to solve for an unknown variable using a simple equation. For the second one, we are going to be distributing throughout parentheses. That was the second example we did in the first video, so we're going to be doing the same thing again. We're going to be distributing throughout parentheses, and this time the equation we're going to be dealing with deals with thermal energy. Okay, thermal energy. Now the equation we're going to be dealing with is Q is equal to mc delta T. Now there are several variations of this that you might come across. Sometimes you'll see Q is equal to mc with a sub p delta T. And sometimes you'll see it written out as this, Q is equal to mc and delta T. The little triangle is called a delta. That's how you read it out loud, mc delta T. But delta means the change in any value, change in any variable. Change in basically means you take the final value minus the initial value. So that's exactly how we're going to fill it in. T final minus T initial. And there are the parentheses we are going to be working with. So the initial equation is Q is equal to mc delta T. Now I'm going to give you the values again. Normally in Project Lead the Way or the POE assignments, you will have to pick out the information from the problem. I'm simply going to list them as is. Okay? So the Q value we're going to be given in this situation is a big number. It's 47,000. 250 in joules. Again, when I list the given information, I have a tendency to write down the units so I have it all in one place. Mass, in this case, is going to be 1.5 kilograms. C, which stands for specific heat, or CP, is going to be 450. And we're going to have T final temperature being 100 degrees. Oh, and the units for specific heat are joules per kilogram times degrees Celsius. Now, what we're going to be looking for is the initial temperature. Again, the purpose or the focus of this video is to teach you guys the math skills, understanding what the units of specific heat are all about, understanding what T final versus T initial is all about. That's a different subject matter, so we're going to be focusing just on the math. So the equation is Q is equal to MC T final minus T initial, so let's plug in the numbers. 47250 is going to be equal to the mass, which is 1.5, times the specific heat, which is 450, times T final, which is 100, minus the initial temperature, which is our unknown value, Ti. So one equation, one unknown, and we're going to have to distribute throughout the parentheses. That's the idea of this sample problem. So before we start the distribution, we have to do some multiplication. We're going to clean up this part of it first, then distribute throughout the parentheses. So 47,250 is still going to stay the same. So 47,250 is equal to, and 450 times 1.5 is going to be 675. So 675 times the quantity 100 minus Ti. Now, I know it seems kind of repetitive to rewrite the entire equation, but it only takes a couple seconds, and it frequently is a source of misunderstanding or source of an error when you start skipping steps or start combining steps. So I have a tendency to write out everything line by line. Now we need to distribute. So the 675 is going to be multiplied by both parts of the expression inside the parentheses. And the fact that we made it 100 is going to make things significantly easier, but let's just complete the process. So it's going to be 47250 is equal to 675 times 100, which is 0, minus, don't forget, don't lose that negative sign, minus 675 T initial. Now the fact that it's a big number as opposed to 5 Ti or 3 T initial shouldn't be the source of a problem. The fact that it's in the hundreds or possibly the thousands doesn't change the way the math actually works. It's a little more numerical values to navigate, but the process is exactly the same. Now we need to finish this off to simplify it. So here is the variable. We want to get it by itself. So the first thing we're going to do is we're going to subtract 67500 from both sides of the equation, minus 67500. And for those of you that are paying attention, you'll see that this will end up being a negative sign. That'll be a negative value. And that's a good thing because this is a negative value over here, meaning our initial temperature is going to end up being a positive value. But you'll see what that looks like momentarily. So 47250 minus 67500 is going to be a negative 20250. Negative 20250 is going to be equal to a negative 675 Ti. And then to finish it off, divide both sides by negative 675. And that'll give us an answer of a nice clean 30 degrees Celsius. Right? And I know it's degrees Celsius because the final temperature was given in degrees Celsius. And it also has the units in the units for specific heat. Now the last thing that I do is in these kind of problems, I tend to do a quick check to see if the answer makes sense. Uh, 30 degrees is the initial temperature. It's going from initial temperature of 30 degrees to 100 degrees. That's because it's absorbing energy. That means it is gaining 47250 units of energy. That makes sense. So that's reasonable. So that's probably going to be the right answer. All right. Now we have two more to do. So let's go through them. The third sample problem I did for you guys dealt with square roots. Okay? Third sample problem I dealt with was square roots. And the easiest example of solving using square roots deals with the Pythagorean theorem. Now, this may be very familiar to you guys. The Pythagorean theorem deals with triangles with sides of a triangle. Now, the equation for Pythagorean theorem is a squared plus b squared equals c squared. Hopefully that's all familiar to you. Where a and b have to be the legs of the triangle. In other words, the sides of the triangle that are connected to the 90-degree angle. C has to be the hypotenuse. There's no other way around it. Now again, I'm going to give you the values, and we're just going to put them in place. I will tell you that this side of the triangle is 18 centimeters. Obviously, that's not 18 centimeters. We'll just say it's rough scale. And this side of the triangle is going to be 22 centimeters. And we are looking for the length of the hypotenuse. All right, pretty straightforward. A squared plus b squared equals c squared. So 18 squared plus 22 squared equals c squared. Punch the numbers into the calculator. Excuse me. Punch the numbers into the calculator. You'll have 18 squared, which is 324, plus 22 squared, which is 484. And for those of you that like being efficient, you can actually punch that all in one shot into most calculators. 18 squared plus 22 squared, and that'll give you the solution to that all in one shot. Equals c squared. Add those values together, you'll end up with 808 equals c squared. And to solve for c by itself, because right now we have it as c squared. We don't want the square of the final answer, we want the final answer. So we're going to take the square root of both sides. So square root of 808 is going to be 28.42 centimeters. Now, your teacher may be a bit of a stickler with what are called significant digits, or how many points after the decimal you fill out. I have a tendency just to stick with 2, so that's going to be my final answer. And then the last type of calculation we did was when you have a variable in the denominator. Variable in the denominator. And we are going to start with a very simple equation, and that's just a speed calculation. Speed is equal to distance divided by time. Very simple equation, but if you have difficulty with variables in the denominator, this is a good place to start. So the speed I'm going to give to you as 50 miles per hour. And we are dealing with miles per hour. Okay, we're not dealing with meters per second or feet per second, so keep track of the units so you know what your final answer should be. And I'll tell you that this thing, whatever the object is, it's traveling 50 miles an hour. You could say it's a car or a truck, whatever you want to think. You could say the distance is going to be 220 miles. We want to find out how long it takes to do that. Well, the equation, again, is just speed is equal to distance divided by time. So speed is going to be 50. Again, I'm going to leave the units out of the equation just so I don't get confused. The distance is going to be 220 miles. And we are looking for the time. Now, to solve for a variable in the denominator, there are several ways you can approach it, but the one that seems to make most sense to my students is to cross multiply. Now, this is not a fraction, but we can easily make it a fraction by just putting it over 1, and then cross multiply. Cross multiplication simply means you take the denominator here